Welcome back. So now we're ready to programmatically access the same MySQL database and perform the same select operations that we did using dbeaver. But before that, I want to go over a few points for why it is important to programmatically access databases instead of using a client like dbeaver. So one of the most important reasons is the GUI-based and command line clients are mainly used for administering databases, not for actually looking at the data. While what we used it for is simple enough, dbeaver lacks many of the features that any programming package would give us to access and communicate with the database. Once we access the data, we are going to do something with it. So we could build a pipeline with it into our data science projects, or we can try to visualize stuff. But these kinds of features are mainly not available in clients like dbeaver because that's not their main intended purpose. So if we want, let's say we want to do some very complex data analysis, or say we want to import the data somewhere and build a predictive model with it. Of course, you cannot do those kinds of things with database clients, such as dbeaver, or even from the command line. So we need to resort to more powerful tools and techniques to do those things. And many programming languages today have these types of features, and Python is by far, at least in my opinion, one of the most robust programming languages to work with data analysis and import data from multiple data sources, including databases. The same thing again, when you want to visualize data, let's say you want to look at the distribution of some sort of data, or you want to build a scatter plot or any type of visualization for that matter. Database clients like dbeaver, they're not designed for that, so they basically do not have that feature. And we usually have to move away from those tools in order to build powerful applications or tools that are driven by our data in the database. So in the next section, we're going to look at how to use Python and a package that is available for Python to connect to a MySQL database. And we're going to perform the same select operations on the employees database that we did using dbeaver. So let's move on. Okay, for this section of the module, we're going to install the Python MySQL connector. I already have Python on my machine, so I'm not going to go through the process of how to install Python. I will provide a link in the resources for you to follow and install Python if you are interested in going through this on your own. But what we're going to do is use something called Python Notebook that helps us execute Python code line by line, so it is easier for you to see and understand. In the resources section, you will also have the opportunity to access the links to get a Python notebook on your machine. It is out of the scope of this module, but if you are interested enough to dive deeper, there's a lot of resources out there to help you do that, and I will give you a few links to those resources. You will find all those links at the end of these slides. So let's move on. So for this session, I already have my notebook open. So what we're going to do is go through the steps that execute the code for us, line by line, and see how we can reproduce the same results that we went through using dbeaver. So the first step, what we're going to do is try to install the MySQL connector package for Python. So this line, when we execute it, it will install the MySQL connector for Python. We use a Python package manager called pip to install that. So I'm going to execute this line. As you can see, it says requirement already satisfied because I already have the MySQL connector Python. But if you're doing this for the first time, it will go through the whole process of installing the package for you. So next, let's import the MySQL connector into our library. This command will do exactly that for us. So if you do not see an error when you execute it, that means it was a success. So not seeing errors is a good thing. So the next step is we're going to provide the same database connection parameters that we provided when we connected to the MySQL database using dbeaver. We need the username, the password, the host, and the name of the database. So this line will do that for you when we do MySQL.connector.connect and provide the username and password and the host and also the database name. If the connection is successful, we will have a handle to the connection, which we will use later on to execute our select statements. So this was a success. You can see now I have executed line 3. So we're good to go. We have a connection handler. So let's run some of the queries. So the first query we want to run is the same query that we used to count the number of employees in the organization. So in the GUI-based version or using dbeaver, you don't see it, but usually there's always a pointer to where our connection is in the database, which is called a cursor. So we're going to use the cursor to execute queries for for us, and then we'll get the results and visualize them. So this line will help us get the cursor from the connection. And this is one query. So this is the same query, if you recall, that we use to count the number of employees. So we formulate the query and then execute the query using this command. So it says cursor.execute, and then you provided the query. It will execute it and hold the results inside it. Now we can see what's inside the cursor by looping over it. This command, if you remember, only returned one row, which was just the count. So we can access the result in the cursor using this notation, which is basically accessing an element within an array of results. In this case, the array has just a size of 1 because, as we saw earlier, it only has a count. So this special statement, we will talk a little bit more about this in the optional section, is basically a quick way to test that what we expect is the correct one. So our expectation is that there are 300,024 employees in the organization, because we've already seen that, and I actually took the number from there. So basically what we're telling the program is to make sure that the result that is being returned is 300,024. If anything other than that is returned, this when we execute this line, we will get an error, which means we did something wrong, or our query was not correct. So when I execute this line of code, I shouldn't be seeing any errors. So let's do that right now. Okay, it executed. There are no errors, which means we did get the result, and it was 324. So this is a quick way of asserting that there are no errors in the execution of this SQL statement. So moving on to the next one, what we did was we asked the database, how many departments are there in the organization? And this is, again, the same query that we used before. So let's repeat the step and replace the query with the older query with this one and see what happens. So you can see the query executed, and we asserted that there are 9 departments within the organization, which is correct. So this was good too. So we can move on to the next query, which is we want to find out how many unique first names there are within across all departments within the organization. And again, the same select query, we're doing a count of the distinct first names from the employees table. So let's execute that. We expect, again, the result to be 1,275. If we get any number, there's going to be an error because we are trying to assert that that's the actual number that we're getting. So this is good too. We are able to get the result and make sure that it was 1,275. So that's a good query. So moving on to the next one, this was the precursor for our next and last query, because as you can see in 1.4.5, we want to know who is the highest paid employee in the entire organization. So if you remember, what we did was first we formulated this query in 1.4.4 and then plugged it into 1.4.5. So for this purpose, I just copy pasted the same query. So what we expect is first to get the employee ID with the highest salary across all departments in the organization. And we expect that to be 43,624. So let's go ahead and execute the query and assert that it is actually that number. Yes, we're good. So now you can see we're almost there. We know which employee we are referring to. It's going to be 43,624, but instead of plugging in the number directly, what we're going to do is use this and compose it with the longer query, just like we did in dbeaver. So let's execute this one and execute. Now, this may be a little overwhelming for you, but you don't really need to understand what all the pieces in this code are. Basically, what we're trying to do here is to assert, after getting the results, to assert that the first name and the last name of the employee that is being returned by our query is going to be this person. So I basically copy pasted the first and last name from our previous query in dbeaver. So when I execute this, if either the first name or the last name is not a match, this assertion is going to fail, and then we understand that we have done something wrong. Hopefully not. So let's see what's inside, or at least let's see if the assertion is successful or not. It is. So with a few lines of code, we have successfully run about 5 queries, the same way we did them with dbeaver, but now we did all of that programmatically. So this is the world of programming as we deal with data. So I hope you have seen how useful programming languages can be when compared to graphical user interfaces. So there are also other ways of accessing data, especially more robust ways, even when using programming languages. Instead of passing SQL statements directly, we may be able to deal with models that are created inside our code that can basically map to each table that you have seen. For instance, take the employees table. Each employee has a first name, last name, they have a salary and other information, such as employee ID. If we were able somehow to find a way to model that table as an object in our code, we may be able to use some tools that will help us map that object to a specific table, so that we don't have to do SQL queries anymore. We basically work with the object. This concept in software development, as it relates to data, is called object relational mapping, or ORM. So basically what we're doing is we are mapping an object in our code, in our program, to a relational table or in a relational database, and hence the name object relational mapping. So it makes it much easier because database, and especially like SQL, is not, it's complicated. It can be very sophisticated, but learning languages such as Python is comparatively much easier. So if you had a way to do the same thing that these SQL statements do for you in a programming language, then that would be hugely beneficial. So we're not going to go through object relational mapping in this video or in this module, but I will provide resources in the slides at the end of this module, where if you are interested, you can try to read more about what object relational mapping is, and of course, go ahead and use some popular libraries whichever programming language you choose. There is one called SQL Alchemy for Python, which you can use to map your objects to relational databases. And it will become a lot more fun because then basically it looks like you write more code than SQL statements, and it makes the process of developing software or creating data science pipelines much easier, and also a lot more fun in my opinion. So this is what the demo is like. At this point, we are done with using like a demo to show you how to use a programming language such as Python to access databases. And what I recommend is, although it is optional, for you to take this notebook, which I will provide in the resources section, and start playing with it. And I will also provide a link to the MySQL connector for Python. That way you can look at the web pages, and there's a lot more examples that you can use to do a lot more than we did here. That way you will have a much better appreciation, hopefully, of how powerful programming languages can be when communicating with databases.